presentation is visible to all of you?
Yes, yes, it is visible.
Yeah,
Yes,
thank you.
yes, yes, Rajesh.
Yeah, thank you so much. Okay, so again, good afternoon to everybody. So today's topic of my presentation, that is a transforming electric vehicle to net zero emissions through green hydrogen technology. So we all of you know, last 10 years we already started our electric vehicle and replaced IC engine to electric vehicle. But now technology move ahead with the green hydrogen technology, so we can achieve our carbon emission, that is your net zero carbon emission. So that is a very good for our planet also. Okay. So, outlines of my today's presentation, starting with introduction, net zero emission. So, that is a most of the student, most of the faculty member, there is a, as well as a research scholar, confused with the net zero emission definition and concept also. Okay. So, starting with the net zero emission, what is a net zero emission and how we can achieve. Then, what is a green hydrogen technology? Because green hydrogen technology, it is a latest trend across the globe, and lot of research scholar, as well as the company, as well as the academic person doing the research on the green hydrogen technology for the vehicle scenario. Okay. Then green hydrogen production mechanism, how we can produce the green hydrogen. Then impact of the electric vehicles on the power system grid. Okay, as an electrical engineer, we are doing the research in the power system grid, as well as the electrical drives, as well as the power electronics. So suppose every IC engine replaced with the green hydrogen technology, otherwise the electric vehicle, then what is the effect of electric vehicle on power system grid? That is the most important thing, because we are charging the electric vehicle to the grid. Okay, so suppose suddenly we can take the lot of current from the green grid, then what happen with the power system grid? And then National Green Hydrogen Mission, in the January 2023, our Prime Minister announced this scheme, that is a National Green Hydrogen Mission. So that is the most important thing. Okay. And finally, we will start conclusion. Finally, we will start the conclusion of our my presentation. Just uh, just wait, just wait. I am just take the break. Okay. So I hope my slide is visible.
Yes, yes.
Yeah. Okay. So I am really sorry for the stop. 1 minute stop. Okay. So now I continue my presentation. Okay. So these are my outlines. Okay. So now we can say the net zero emission. What is a net zero emission, and why people going with the net zero emission? So it is a, so we can reduce our the greenhouse effect. Correct. So net zero emission refer to achieving an overall balance between the greenhouse gas emission produced and the greenhouse gas emission taken out the atmosphere. Okay. So most of the research scholar, as well as the faculty member, confused with the net zero emission. Most of the faculty, as well as research scholars, saying net zero emission means we can produce the 0% of the carbon. So that is a not possible. We have a advanced level technology, but somehow we can produce the carbon emission. That is a correct, no issue. But how we can achieve the net zero emission? Okay, so it means in the simple language we can say, suppose you produce the 10% of the carbon emission in the environment throughout the production of the any vehicle, yeah, any device. Okay, maybe the power electronics component, maybe the any device, maybe the AC, maybe the TV, yeah, any component. Suppose you are designed and you produce maybe the 10% of carbon emission in the environment. Okay, then you have to reduce this 10% of emission, that 10% of carbon emission from the environment. Okay, so then you produce the 10% of emission. Okay, then again you have to reduce this 10% of emission from the environment. Then we can say our technology, yeah, our product, it is 100% net zero emission. Otherwise, we can say the 100% pollution free. Okay, so this is a proper definition and simple concept of the net zero emission. Okay, but we cannot make, otherwise we cannot design the any electronics item, any electric vehicle that is like 0% emission of the carbon. That is not possible, because everywhere we can utilize our thermal power plant, our solar energy. Suppose you can say our solar is a 100% carbon free. It is not like that. We can produce the solar energy, we can produce our electrical energy from the solar panel, and while you design your solar panel, that time you will produce the carbon. Okay, and add the carbon percentage in the environment. Okay, once you design your solar panel, then we can say our electricity is 100% free from the carbon. But while design the solar panel, you can add maybe the 10%, yeah, maybe 20% the carbon emission in the environment. Okay, suppose you add this carbon in the environment, then you have to also reduce, otherwise you have to also minimum the carbon emission from the environment. Okay, so this is a net zero emission. We can say step one, that is know your data. Okay, while design the any item, so you should know how much carbon emission we can add in the environment. So first step, you should know about the data, how much percentage of carbon you can add in the environment. Then step two, manage your demand. Okay, suppose you continue add the carbon emission in the environment, so you have to also manage your demand. Suppose you are a industry person and you are design the solar panel, so you cannot uh, uh, compromise with the production. Okay, as a business policy, you cannot compromise with the production demand. Okay, so you have to also manage your demand, and you have to also think on the net zero emission. And finally, make the challenges how we can reduce this carbon from the environment. So this is a simple three step to achieve the net zero emission. Okay, now introduction to electric vehicle, because main topic is your main topic of this session, that is your transforming the net zero emission to the green hydrogen technology for the electric vehicle. So before going to detail about the green hydrogen technology, first we should know about the what is the electric vehicle. So I am not spending too much time on this slide, because all of you know and were aware about the electric vehicle, but I want to spend only 1 to 2 minutes on the major components of electric vehicle. So transport is a fundamental requirement of the modern life. This is not for India, this is not for USA. Across the globe, transportation is a main requirement for the any country. But traditional internal combustion, that is IC engine, are quickly becoming the outdated. Why outdated? Because IC engine produce the lot of carbon emission in the environment. Okay, so we can try to reduce the CO2 by replacing IC engine by electric vehicle. Okay, so while we can say the electric vehicle, then what is the meaning of electric vehicle? So petrol and diesel vehicle are highly polluted and are being quickly replaced by fully electric vehicle and hybrid electric vehicle. Yes, so we can replace the IC engine by electric vehicle as well as the hybrid electric vehicle. So what is electric vehicle? So electric vehicle is nothing but simple. We can replace this IC engine, that is a petrol tank and diesel tank, by our electric motor. Okay, so we don't have a requirement for the fuel tank. Okay, then we can say it is a 100% electric vehicle. Okay, so and then hybrid electric vehicle means we have both. There is a electric vehicle as well as the fuel tank, then we can say the hybrid electric vehicle. So you can see figure 1, a schematic layout of the electric vehicle as well as the hybrid electric vehicle. So you can see starting from the left hand side, there is a front wheel. Okay, so this is your front wheel. Then mechanical transmission shaft. So you can see from here, there is electrical energy transmit to the mechanical shaft. So our wheel is rotated. Okay, and this is your motor as well as generator. Why generator? Because most of the electric vehicle work on the regenerative braking system, so we can increase the efficiency of electric vehicle. Okay, so that's why here is the motor as well as the generator. So we can say BLDC motor, PMSM, SRM, as well as the induction motor. Okay, so nowadays people use induction motor, BLDC motor, PMSM, and SRM motor to run the electric vehicle. To control the speed of this motor, we require the power electronic circuit. So obvious, power electronics is the heart of the any application. And as a theme of this FDP, there is a power electronics technology, otherwise power electronics theme. Okay, so we can say power electronics is the heart of the any application. So using power electronics, we can control our voltage and frequency. So we can able to control the speed of our motor. Okay, so power electronic circuit, then we need to energy storage system. Obvious, we need to store the energy to give the power of our motor as well as our converter. Okay, so there is an energy storage system. So once we have an energy storage system, then we have to synchronize our speed controller as well as the torque controller with the power converter algorithm. So we need to use the control algorithm. Okay, so we need to use the any control device. Okay, so maybe that is a hardware device, that is your FPGA, DSP, microcontroller. So depend on your clock frequency, you can use any devices, that is a FPGA, DSP, and microcontroller. So FPGA nowadays people use because it is a high clock frequency. Okay, so that is your field programmable gate array, that is your FPGA, and DSP and microcontroller, all of you aware very well. Okay, so software, that is maybe the direct torque control, maybe the field oriented control, maybe the any advanced level control you can implement depend on your requirement. Okay, so this is a throughout the electric vehicle. Suppose you want to design the hybrid electric vehicle. So as I said in previous, we need to add the fuel tank to make the hybrid electric vehicle. So this is your fuel tank and this is your IC engine. Then we can say this is your schematic layout for the electric vehicle and hybrid electrical vehicle. Okay. So one of the requests from my side, if you have any question, then please note down the slide number. Then once I complete my session, then we will discuss on the question answer session. Okay. Otherwise, there is a disturbance in between the. Suppose I give the answer of your question, then disturbance. So normally I prefer the question answer end of my presentation. Okay. So suppose you have any question in the particular slide, then you can just note down the slide number and your question. Then we will discuss in the end of the presentation because we have a sufficient time for this session. Okay. Then next one is a components of electric vehicle. Suppose somebody want to design the electrical vehicle, and suppose somebody want to do the research on the electric vehicle, then we should know about the fundamental concept as well as the what are the major component used to design the electric vehicle. Okay, so this is a not like only physical design, it is a both, there is a physical design as well as the simulation part. Okay, as a design of the electric vehicle, this is a not the task of the single engineer, it is an involvement of the electrical engineer, mechanical engineer, as well as the chemical engineer. Lot of engineers are involved, and then finally we can design our electric vehicle. It is a not only single person task. Okay, it is a involve many engineers to design of the electric vehicle. Okay, suppose you are a research scholar as well as the faculty member, then we can say, suppose we want to do the research on the electric vehicle as well as the hybrid electric vehicle, then major components are accelerator and brake. I am not going to detail about what is accelerator and what is a brake. You all of you know. Then we have a three major components: electric propulsion system, first one; energy source subsystem, second one, and auxiliary subsystem, third one. So we have total three subsystem to design the electric vehicle. So let's see, we can discuss one by one. So electronics controller, okay, in the part of the electrical population subsystem, electronics controller, that is the most important. Maybe you can use the FPGA, DSP, microcontroller to make the control algorithm. That is the electronics controller. Power converter, there is a power electronics. As I said, power electronics is the heart of the any application. Maybe the small application you can say the computer, maybe the small application you can say the BLDC ceiling fan. Everywhere, heart is a heart of the any application. There is a power electronics. Without power electronics, we cannot make any effectively device. That's why I am telling heart of the any application there is a power electronics. You can take the small example, even your mobile phone, even your laptop mouse, even your classroom projector, everywhere is power electronics. Okay. Then electrical motor, depend on the vehicle, you can choose any type of motor, induction motor, BLDC motor, PMSM, SRM, any type of motor. Then it is a mechanical transmission shaft to transfer the mechanical power from the electric motor. And this transmission shaft is connected with your wheel. Okay, maybe the four wheel, maybe the two wheel, maybe the three wheel, depend on the type of the vehicle. Because of the two wheel vehicle also available, three wheel vehicle also available, and four wheel vehicles also available. And nowadays people going with a electric train. Okay, so this is the electric population subsystem. Then energy source subsystem. So energy management unit. So we have to manage the energy because that is synchronized with the power electronics converter as well as the your control algorithm as well as the your electric motor. So we have to manage the energy because in the electric vehicle there is a not only in the motor available. There is a other auxiliary device available like the mobile charger and like a radio system, like TV. There is a like small level TV. Everything's available in the electric vehicle. So we have to manage the energy for this all the component. Okay. Then energy source, from where you will get the energy, and energy refueling unit. Okay. So here is maybe that is your energy, maybe the petrol, yeah, maybe the diesel, yeah, maybe the your electrical energy. Okay. So this is a component for the electric vehicle as well as the hybrid electric vehicle. Okay, and this is an energy source. So as a maybe the energy refueling is maybe the petrol and diesel. Then here is your petrol pump and diesel pump. Suppose this is a energy, the electrical energy, then it is a your battery station. Okay, so this is a second component. Third component, that is a auxiliary subsystem. So auxiliary subsystem, there is auxiliary power supply. Okay, for the auxiliary item, maybe your charger, maybe your entertainment device. Okay, then temperature control unit. Of course, because we have a battery, so we have to control the temperature of the battery. That is a battery management system. Okay, and nowadays hot topic, that is a battery management system. How we can manage the battery so we can improve the efficiency of our vehicle. Okay, and finally power steering unit. Okay, so power steering unit, that is not a part of electrical engineering, but that is a part of the mechanical engineering. Okay, so you can see, so we have around like 10 to 12 component, major components. So every component we should involve with a different type of engineers. Okay, maybe the electrical, maybe the mechanical, maybe the chemical. Okay, as a chemical engineer, we can say the battery management system, there is a temperature control. Okay, because battery is nothing but chemical energy, correct? So we can convert the chemical energy from the electrical energy. So that's why we can say to design of the electric vehicle, we need to require the chemical engineers also to manage the battery part. Okay, and nowadays hot topic is a, because electric vehicle is blasting. You heard about the news, from the news, electric vehicles blast. Why blast? Because of the continue supply the current to the battery, and battery is nothing but chemical property. Okay, so after the saturation, battery will blast. So that's why ultimately fire the electric vehicle. Okay, so I hope these components you understood very well. Okay, still you have any questions, so please write down your question and slide number, so we will discuss end of the this session. Yes, so why we are going going to electric vehicle, we have already well established IC engine from the last maybe the 100 year, maybe the 200 year, maybe the 300 year. Okay, so why we want to replace IC engine? So what are the benefit of electric vehicles? So lower learning cost, yes, of course. When you purchase the electric vehicle, then cost is very high. But while you running on the bike on the road, then ultimately maybe we can say the life of the electric vehicle there is a low cost, because nowadays petrol and diesel price is very high compared to the electrical energy price. Okay, so that's why we can say once the time we have to invest the amount on the electric vehicle, but during the running condition your cost of the electric vehicle is ultimately low compared to the IC engine. Low maintenance to cost, that is the most important, because there is a no any rotating device, only one rotating device, that is your motor. Apart from motor there is a no any rotating component in the electric vehicle. And you can say in the IC engine itself there is a rotating device. Okay, so that's why we can say in the engine, in the case of IC engine, there is a engine itself, it is a rotating component. Many rotating components are there in the IC engine, so that's why we need to give the regular maintenance. But in the case of electric vehicle there is a low maintenance, only we have to do the maintenance because of the rotating machine, and that is a rotating motor. Petrol and diesel used to destroy in our plant. You all of you know very well, because nowadays there is a effect of the global warming, and recently you can say without the rainy season nowadays many states there is a lot of rain. Okay, why lot of rain without the rainy season? Because of the this is the effect of the greenhouse effect. Okay, tax and financially benefit, there is a very good. Suppose you want to buy the electric vehicle, then also government support you in the case of the taxes, as well as the provide the financially support for the subsidy in the case of in the terms of the subsidy. Okay, so these taxes and subsidy that depend on and vary, that is a state to state. Okay, no noise pollution, obvious, there is a no any rotating part, less rotating part, as well as the no petrol and diesel, so obvious there is a no noise pollution. So these are the major benefits of the electric vehicle. Yes, so we have, these are the benefits. So why we can go with the hydrogen vehicle? Okay, so issue with the battery operated vehicle. So we know every electric application, otherwise every operating system, it is not 100% correct. Okay, so every application has some disadvantage. So what are the disadvantage of the electric vehicle? Size of the battery, charging time of the battery, and not possible to long drive. So these are the major concern nowadays in the electric vehicle. That's why people are not going to buy the electric vehicle. So first one is the size of the battery. Okay, suppose you increase the size of the battery, then you reduce the efficiency of electric vehicle. So I'm not going to give the detailed explanation on the technical term, so because of the less time, but I can say suppose you increase the size of the battery, so it will reduce the efficiency of electric vehicle. Charging time of battery, so nowadays people are working on the fast charging, but still it need to 3 to 4 hours to charge our electric vehicle. Suppose you have a fast charging as well as. Okay, so there is a nobody want to stay to charge electric vehicle to take 4 to 5 hours, yeah, 6 hours, yeah, 10 hours. Nobody want to stay for that. Not possible to long drive, this is the most important thing. Suppose you want to drive maybe the 1000 kilometer, yeah, maybe the 500 kilometer. Okay, yeah, maybe the more. Okay, so there is a not possible by single charging of your electric vehicle. Okay, so suppose you want to drive from maybe the Tamil Nadu to Delhi, and maybe the distance is maybe the 1000 kilometer, and suppose you have electric vehicle, so that is a not possible to drive in the single charging of your battery. Okay, so these are the three major disadvantage of the electric vehicle. That's why people move ahead with the latest technology, and that is your green hydrogen technology. Yes, so up to this, there is a background of the electric vehicle, and now we move ahead with the green hydrogen technology to reduce the net zero emission. So green hydrogen technology. So here is only two terms, that is a green and second one is hydrogen and third one is a technology. Technology is of course that is a very well, as well as the hydrogen, it is a very well known to all the people because hydrogen is nothing but H2O. Okay, so we have to get the hydrogen from the water as well as the other components. Okay, so green hydrogen is a hydrogen which is generated by renewable energy or from the low carbon power. Okay, so we have 3 to 4 type of hydrogen across the globe. So there is a gray hydrogen, black hydrogen, and green hydrogen. So we will discuss type of the hydrogen. Okay, so green hydrogen means hydrogen which is generated by renewable energy. Otherwise, that is a from the low carbon power. Then we can say it is your green hydrogen. Okay, because hydrogen we can produce by the electrolysis. Okay, and while the electrolysis process, you can give the external power supply. There is a DC power supply. Okay, so that DC power supply you can produce by the renewable energy source, and then suppose hydrogen will you can produce the hydrogen, then you can say our hydrogen is a green hydrogen. Okay, so you can see the process of the green hydrogen. Okay, so renewable electricity generation. So maybe this is a wind energy, maybe the solar energy, maybe the biomass energy, any type of energy you can utilize to generate the electricity. Okay, so this is about 100% renewable energy. Okay, getting the electricity to the electrolyzer. So as I said, to generate the hydrogen, suppose you have a H2O. Okay, so here is we have a two atom of the hydrogen and one atom of the oxygen. So you have to take the hydrogen outside and oxygen also outside. So we need to give the power supply, that is a DC voltage. So this DC voltage you can take from the renewable energy. Okay, and here is a electrolysis process. Okay, so you can get hydrogen from this electrolysis process. Once you have a hydrogen, okay, then you can store the hydrogen, okay, in the storage tank, and then you can distribute and storage the hydrogen. Okay, you can otherwise use the directly hydrogen to any application. Otherwise you can store the hydrogen and then you can use this hydrogen in the any application. And finally we can say whatever is our device operate, maybe the big vehicle under the sea, maybe the bus, maybe the electric vehicle, maybe the any home appliances, yeah, industry appliances that use the electricity by the green hydrogen, then we can say ultimately the net zero emission. Okay, but again, here you use the solar panel and the wind turbine. While design the solar panel and wind turbine, it produce the maybe the 10%, yeah, 20% of the CO2. But you have to reduce this CO2. Okay, by maybe the any technology. Maybe you can produce the maybe you can produce the maybe the high power from the hydrogen, maybe the hydropower plant, something like that. Okay, so that is up to you. Okay, yes, classification of the hydrogen. So as I said, we have a 4 type of hydrogen. There is the brown hydrogen, gray hydrogen, blue hydrogen, and green hydrogen. So I am just spending only 1 minute here because this is a totally topic of the chemical branches, but we should know why there is a green hydrogen. Okay, so brown hydrogen means hydrogen produced when the coal is transformed under the high pressure. Suppose you can produce the hydrogen by the thermal power plant, and that is a very high CO2. Then you can say this is the brown hydrogen. Gray hydrogen, gray hydrogen produced when the natural gas is transformed by the burning the methane. Okay. Then carbon dioxide is a release back into the air. Okay. Then you can say it is a gray hydrogen. Okay, by the natural gas. Okay. Blue hydrogen, hydrogen produced from the natural gas. Okay, produced from the natural gas, but the output of carbon dioxide is a capture and store. So whatever is a carbon dioxide is produced while production of the hydrogen, that carbon dioxide you can capture and store. Then we can say it is a blue hydrogen. Okay, and finally green hydrogen I already discussed. There is a hydrogen extracted from the water using the many methods available, maybe the electrolysis, maybe the any other method you can utilize. Okay, nowadays many methods available to extract from the hydrogen from the water. Okay, so these are the four type of hydrogen. Now, slide number 10, that is a carbon footprint of the hydrogen. Okay, so as a research scholar, we should know, suppose we can use the brown hydrogen, then what is a carbon footprint? Suppose we can use the gray hydrogen, then what is a carbon footprint? So as a research scholar, we should know carbon footprint of the all these type of the hydrogen. Suppose you can use the gray hydrogen, then carbon footprint for the 1 kilogram of CO2. So 1 kilogram of production of hydrogen, suppose you want to produce the 1 kilogram of hydrogen, then how much kilogram of CO2 produced? So for the gray hydrogen, that CO2 is produced 9 to 12 kilogram for the production of the 1 kilogram of hydrogen. Okay. Suppose you want to produce the 1 kilogram hydrogen and you can use there is a blue hydrogen, okay, blue hydrogen technology, then you will produce the CO2 that is a 1 to 4 kilogram, okay. And suppose there is a green hydrogen, during the green hydrogen we can produce only 0 to 0.6 kilogram of the green kilogram of the CO2 for the production of the 1 kilogram of the hydrogen. So you can see gray hydrogen, it is a very dangerous, then blue hydrogen, and then finally green hydrogen. Okay, so we can say green hydrogen production is a very less while produce the green hydrogen, so it will produce only 0 to 0.6 kilogram of the CO2. Okay, so green hydrogen production mechanism. Okay, so this is a simple mechanism, but issue is the storage element. Okay, how we can store the element hydrogen. So maybe the offshore wind turbine. Okay, maybe the triad energy. So ultimately this is a renewable energy source, and green electricity produce the hydrogen. This is a electrolysis process. And finally you can storage element, so maybe you can storage tank, yeah, maybe you can utilize any other type of technology to storage the hydrogen, because hydrogen is a very explosive material. Okay, so you have to take care about the storing. Okay, and there is a one of the major concern for the design of the green hydrogen vehicle. Okay, how we can store the hydrogen. So once the hydrogen is stored, then you can transport through the network and ultimately utilize in the any application. Then finally we can say the zero carbon heating for the homes. Maybe suppose you can use this hydrogen in the domestic application. So you can see the slide number 12. Here is the how we can produce the hydrogen. So this is the hydrogen electrolysis process. So you can see this is a DC power supply. So this DC power supply is required to production of the hydrogen. So you can suppose use this DC power by the renewable energy sources, then we can say our hydrogen is a green hydrogen. So this is a simple equation. Okay, there is a we have a water liquid, okay, H2O. Then we have to take the H2 atom different and O2 atom also different. Then we can say that we can produce the dry hydrogen gases and dry oxygen gases, because two molecular of the hydrogen and two molecular of the oxygen. Okay, so this is a simple equation and simple process. But suppose you want to generate the hydrogen, so this process is not a simple, is a practical case. Theoretical case, we can say this is a simple atom, we have only two atoms, there is a H2 and O. But suppose you want to produce maybe the 1 milligram of hydrogen, then it will take too much time and it will make sure to safety issue. Okay, as a chemical person, they know very well. Okay, because hydrogen is very dangerous. Yes. Slide number 30, schematic layout of power by the hydrogen fuel cell electric vehicle. So starting from the renewable energy sources, then DC to DC converter, because we have to make the constant DC link voltage for the electrolysis process, because whatever renewable energy source, maybe the wind energy, maybe the solar energy, maybe the tidal energy, maybe the any kind of renewable energy, output power is not a constant. So you want the constant output power for the electrolysis process. That's why here we use the DC to DC converter. Okay, This DC to DC converter may be the step up, maybe the step down, depend on the renewable energy sources. Okay. So once you have a DC to DC converter and DC link constant voltage, then you can use the electrolysis process to production of the hydrogen. Okay. So once the hydrogen you can produce, then you can store this hydrogen in the hydrogen tank. Okay. And this storage of the hydrogen, there is one of the major concern. Okay. Because this is a very dangerous. Okay. Suppose in the environmental hydrogen is leaked, then there is a very dangerous to the environment. It is a very energy full compared to the RDX. Okay. So there is a major concern to store of the hydrogen. Once you can store the hydrogen, then you can convert this hydrogen energy into electrical energy. So this is your power electronic circuit. That is a power electronics converter plus battery. Okay, done. So maybe you can directly use this hydrogen by the fuel cell. Okay, and you can convert this constant DC link voltage and you can give your electric motor, maybe the DC motor, yeah, maybe the AC motor. Depending on the motor, you can use your converter here. Okay. Okay. So depend on the motor, you can utilize your converter here. Okay. And then finally, this electric motor is inside your hydrogen fuel cell electric vehicle. Okay. So this electric motor is connected with the your transmission shaft as well as the wheel. Okay. So these are the schematic layout that is powered by the hydrogen fuel cell electric vehicle. So simple way, I can say there is a major three component. As an electrical engineer, we can say we have only three major components. One is the electric motor, fuel cell, and hydrogen tank. Okay. So once we have a hydrogen storage element, then by using the fuel cell, we can convert that hydrogen energy into the electrical energy, because hydrogen is only one type of fuel. So that is not the electrical energy. To convert that fuel, that is a hydrogen from hydrogen to electrical vehicle, we can use the fuel cell. Okay. So that is a different topic. So how we can convert the energy from the hydrogen to the by using the fuel cell. Okay, how we can convert the energy. Okay, so there is another topic. Okay, but while using the fuel cell, we can convert hydrogen into electrical energy. Okay, by reaction of the air. Okay, so this is a simple thing. And output of this electrical fuel cell electric vehicle, there is only water and heat, and there is a not water is too much, only drop. Okay, so there is a not issue. So working principle, I am not going to detail about working principle. Just I give the important uh, important topic on the working principle. So you can see the hydrogen atom is split into the proton and the electron. Okay. In the case of the hydrogen, we should know about the hydrogen is split into the proton and electrons. The electrons, and especially the steady flow of the electrons. Okay. It is a steady state flow of the electrons. Correct. Are the electricity used to operate the electric motor, and that is a drive the vehicle. Okay, it's simple. So once we have a motor, so you can directly give the electricity to motor. So motor is running, and that motor is connected with our transmission shaft, and transmission shaft is connected to the vehicle wheel. Okay. While the fuel cell is produce the electricity, the protons from the hydrogen combine with the oxygen from the air to produce the water. Okay. So once you have a hydrogen storage tank, then we have to externally give the air. You can see here is the externally we can give the air to the fuel cell. So input of the fuel cell, that is one is the air component, and second is the hydrogen component. Combination of the air and hydrogen, we can produce the electricity, and that is nothing but a fuel cell. Okay. And the only drain that hydrogen electric vehicle produce is the water vapor. Okay, so output of the electric vehicle, there is not any emission but only drop of the water. That is the most important thing. Okay, done. So there is a total three subsystem. One is electricity, second one is a hydrogen, and third one is a propulsion. Okay, so electricity, so you can see green one, that is your electricity, then second one, that is hydrogen, and red one, that is your mechanical propulsion system. Okay, so these are the major component of the internal structure of the green hydrogen vehicle. Okay. Yes, slide number 17, that is your overall control scheme for the green hydrogen vehicle. Okay, So I already discussed this the major component as well as the stream of the green hydrogen, but also I want to spend some time because this is a power electronics converter, okay, and theme of this FDP, that is a power electronics. So here we can use many DC to DC converter as well as the DC to AC converter. So depend on the vehicle types, maybe the two wheeler, maybe the three wheeler, you can use maybe the one type of DC converter, two type of DC converter, yeah, three type of DC converter. So depend on the size of the electric vehicle and types of the electric vehicle. Okay. So there is a DC to DC converter. Here is also DC to DC converter. Here is also DC to AC converter, and this is a bidirectional. Why bidirectional? Because as I said, we can use motor as well as generator. Why? Because of the regenerative braking. Once you have a regenerative braking, then we can store our electricity from the motor. So that is a very good. So we can ultimately increase the efficiency of the motor, efficiency of the overall vehicle. Okay, done. Okay. So we have a electric vehicle, we have a IC engine, we have a hybrid electric vehicle, and now fourth one, that is your hydrogen vehicle. So we can compare our hydrogen vehicle with battery operated electric vehicle. Okay. So this is a slide number 18. That is a comparison table for the comparing of the electric vehicle with a hydrogen vehicle. So definition, there is an electric car or battery generated car which run through the power generated by the battery. Okay, so this is a battery operated vehicle. Okay, so that is a power by the battery. Okay, hydrogen vehicle means it is a power by the hydrogen. That is your hydrogen operated vehicle. Okay, done. And second one, second topic that is a second topic, otherwise we can say the second comparison parameter, that is a powering and refueling time. Powering electric car when recharged usually take hours, 4 to 5 hours. Okay, but for the hydrogen car, when fuel refuel take less time, that is mostly 4 to 7 minutes. Okay, this is the same like petrol and diesel. Okay, once we have a hydrogen station, then it will take only 4 to 7 minutes. That depend on the vehicle type. Even suppose you have a two wheeler, then it will take only 1 minute. Okay, so it is a hydrogen pump. It is the same like petrol pump. Okay, but we need to take care about the storage. Okay, how we can store the hydrogen. Okay, done. uh, then third one, there is a pros. They run on the battery and do not cause by any harm to the environment. Only harm to environment while design of the battery. Okay, that time maybe CO2 is emitted in the environment. Okay, but once you have battery, then there is a CO2 is very less. Hydrogen fuel does not take year and year together to form the compound of the petrol and diesel. So we can quickly make the hydrogen. It is not like it will take maybe the 1000 year to design to production of the petrol and hydrogen. It is not like that. Cons, it will take high time to recharge the battery. Okay, it will take the high time to charge our battery, but in the hydrogen it is very high cost because cost is very high. Range, so range is depend on the many parameter. Okay, and lot of research scholar doing the research on the range of the electric vehicle as well as the hydrogen vehicle. So range, we can say it depend on the many factor like number of passenger, if the air condition is on or off, the condition of the road. So what is the condition of the road it is traveling on, whether it is a long straight road from the bumper full road. Okay, so there is a many parameter. Road is a straightforward road, traveling is long traveling, AC is on or off, entertainment device is on or off. Okay, in the hydrogen vehicle, electric car can cover 100 to 200 mile in one go, but hydrogen car cover 300 mile. Okay, so hydrogen car we can drive long running. Okay, so there is a very good for the hydrogen vehicle compared to the battery electric vehicle. So I'm not going to discuss about the features of the hydrogen vehicle. So just I want to spend 1 minute on the fuel cell electric vehicle. Okay. So features, what are the features? very little emission. Okay, so of course there is a green hydrogen, so very little emission, high efficiency, not dependent on electrical supply, high price, and available commercially. So there is a features of the fuel cell electric vehicle, but problem, cost of the fuel cell is very high, feasible way to produce the fuel because there is a very dangerous to production of the hydrogen, and availability of the fueling facility. Okay, so generally this type of hydrogen pump not available commercially in the market. Okay, it will take some time. Okay, because issue with the storage of the hydrogen. Yes, so till now we discussed the electric vehicle as well as the hybrid electric vehicle. It is okay. Suppose we can do and we can make the hydrogen vehicle as well as the electric vehicle. Then effect of the electric vehicle and hybrid electric vehicle on the smart, on the not smart grid, on the power system grid as well as the environment. Okay. So we can say impact on the power grid, second impact on the environment, and third impact on the economics. So there are total three impact. So first impact on the power grid, second impact on the environment, and third impact on the economic. So let's see what are the impact on the power grid. So impact on the power grid, that is a positive impact as well as the negative impact. So first let's see positive impact. Facilitating the smart grid. Nowadays there is a smart grid. Every grid is replaced with a smart grid as well as a smart meter. So I'm not going to discuss about what are the smart grid and smart meter. Okay, because of the limitation of the time. Vital grid operation is possible. We can connect our vehicle to directly grid. So V2G technology is possible. Otherwise, we can say V2X. Okay. Nowadays, also few research scholars are working on the V2X technology. X stand on any application, any device we can connect with our vehicle. Okay. Integration of the renewable energy sources. So that is also possible. So these are the positive impact on the electric vehicle. Now let's see what are the negative impact. Voltage instability. There are that is a negative impact. Okay, increase the peak demand. Suppose you charge your electric vehicle, so it will take too much current. So suddenly it draws the too much current. Okay, so there is a suddenly increase the demand. Suddenly increase the current demand. Okay, harmonics. Of course, there is a power electronics converter. Of course, harmonics is there. Voltage sag and power losses. So these are the negative impact on the power grid. Second impact on the environment, less green hydrogen gases emission. Of course, suppose we replace the every IC engine with electric vehicle, then less greenhouse gas emission. Okay, and impact on the economic, there is a lower operating cost, chance to benefit from vehicle to grid. Of course, in the initially stage, we have to invest too much price, too much amount to buy the electric vehicle. But as a long time, it will benefit. Okay, so these are the effect of the electric vehicle and hybrid electric vehicle. Yes, as I said in the beginning of the presentation, every system is not 100% correct. Okay, so few limitations are there. So first limitation, there is a social problem. Okay, third one, second one, that is a technological problem, and third one, there is a economic problems. Okay, so what are the social problem? Social problems, that is a social acceptance, is a common way people they cannot buy electric vehicle because price is a very high. So as a we can say as a lower class family, they cannot afford to buy the electric vehicle because price is very high. Suppose you can buy the IC Honda, okay, that is your uh, Activa, that is based on the petrol, okay. So that price is maybe the 90,000 rupees. But suppose you want to buy the electric vehicle, okay, there is the same two wheeler. So maybe that price is a 1.5 lakh rupees, okay, maybe the 1.6 lakh rupees. So depend on the company to company, okay. The amount is very, there is a company to company, okay. Insufficient charging station, okay. So there is a social problem because there is a not available the sufficient charging station to charge our electric vehicle. Technological problem, limited range is also limited, okay. long charging period, there is a problem, and safety problem. Okay, so these are the problem for the technological issue. Okay, because nowadays you are heard about the two-wheeler is maybe blasting, three-wheeler electric vehicle is blasting. Most of the time two-wheeler is blasting because of the battery issue. Okay, there is a battery management system. Economical problem, higher price. Of course, price is very high. We can reduce the price by the supporting of the central government as well as state government. Then we can slowly reduce the price of our electric vehicle. So these are the few limitations of the electric vehicle. So what are the tentative solutions of the current limitation of the electric vehicle? Otherwise, you can say the green hydrogen electric vehicles. Okay. So limitation, there is a limited range, battery energy source and energy management technology. Okay, that is a limited range. Okay, long charging period. Okay, so probable solution, better charging technology. Okay, so limitation is a long charging period. So what are the probable solution? So we can design the better charging technology, so we can do it. Okay, that is a possible. Okay, safety problem, advanced manufacturing scheme and build the quality, that is also possible. Okay, we need to do the analysis on the material property, so we can say advanced manufacturing scheme as well as the build the quality. Insufficient charging station, so there is an insufficient charging station, then we can say probable solution, placement of sufficient station capable of the providing service to all kind of vehicle. So we can make the very good amount of the charging station. Higher price. So what are the probable solution? Mass production. Okay. One of the solution is mass production, advanced technology, and third one is a government initiative. Okay, so suppose government is provide the subsidy and maybe the tax benefits, so we can reduce the price. Okay, so these are the tentative solution. Maybe the somebody want to do the research on the electric vehicle as well as the fuel cell electric vehicle, then they can take this type of problem to how we can resolve this issue, so we can contribute into our society. So footrest in the key electric vehicle, otherwise we can say hybrid fuel cell electric vehicle. Recharging, okay, weight of the charger, durability, cost, recycling, size, charging time. Okay, so these are the footrest. Suppose as a research scholar, we can take recharging topic of the battery, so we can solve the problem by considering the weight of the charger, durability of the charger, cost of the charger, recycling, how we can recycle the battery, size of the battery, and charging time. So these are the key factor to do the research on the recharging issue. Second issue, there is a hybrid electric vehicle. Battery issue, durability, weight, and cost. Okay, cost is a main issue, and the second one is the weight. Suppose you increase the weight of your overall vehicle, then you can give the more power to drive your vehicle. Okay, hydrogen fuel cell, cost, hydrogen production, infrastructure, storage, durability, and the reliability. So these are the footrays while you going with a hydrogen fuel cell vehicle. Auxiliary power size, there is a auxiliary power unit, there is a size, cost, weight, durability, safety, reliability, cooling, and efficiency. So these are the food trays. Suppose you want to do the research, otherwise suppose you want to work on the auxiliary power unit. Okay, so these are the food trays in the key of the electric vehicle factor. So major trends and future development, vehicle to grid connection, that is possible. Yeah, vehicle to X connection, that is possible. Better charging topologies. Okay, yes, we can do the better charging topology. Better battery technology. Obvious. Nowadays people are going with the ultra capacitor, super capacitor. Okay, instead of the battery, lithium ion battery. Wireless power transfer, yes, in the foreign country, wireless power transfer is also possible. And in the India, we are working on the wireless power transfer. But as a Indian situation in India geometric condition, it will take maybe the 15 year, maybe the 16 year. because of the road situation and the geography of the Indian location. Green hydrogen fuel. So we need to produce the green hydrogen high and high so we can reduce the net zero emission. So these are my second last slide, most probability. What are the challenges nowadays are the green hydrogen technology? So what are the challenges? Suppose you want to do the research, otherwise maybe you want to design the green hydrogen electric vehicle, then what type of challenges you are facing? First challenge is there is a process of the electrolysis is expensive. So process of the electrolysis is very high expensive. Okay. Then storage of the hydrogen is complex as it is a weight and volume are very high because hydrogen is ultimately gas. Okay. So storage of the hydrogen is very complex as it is a weight and volume are very high. Okay. Cost about 3 times as much as natural gas. So suppose you compare the cost of the hydrogen with your natural gas, maybe the CNG, yeah, maybe your diesel and petrol. So cost of your hydrogen is very high. Okay, so these are the three challenges from my experience as well as my research point of view. So first one is the process of electrolysis is very high. Second one is the storage of the hydrogen is very complex because hydrogen is a very explosive material. And finally, cost is 3 times high compared to the natural gas. So these are the three challenges nowadays people are facing to design the green hydrogen electric vehicle. So current area of the research, okay, and suppose you want to start your career in the green hydrogen vehicle. So what are the current area of the research? Reduce the mass of the overall vehicle. So we can reduce the mass of the overall vehicle. So we need to give the less amount of the energy to drive our vehicle. Okay. Hydrogen production mechanism. So how we can produce the very fast hydrogen production. Okay. So we can give the more hydrogen electric vehicle in the market. Improving the hardware so we can make the very rugged body of our vehicle. So how we can improve the hardware? Okay, hardware means body of your vehicle. Okay, increase the efficiency and life of the battery. Okay, so how we can increase the efficiency of battery as well as the life of the battery, because there is a state of the health, state of the charge, there is a SOC. Okay, so there is a state of charge as well as the state of the heart. So these are the current area of the research. This is a final topic, that is your national green hydrogen mission, and this is the last one. Okay, then I will stop my presentation and then we will discuss on the question answer. Okay, so what is a national green hydrogen mission of India? Okay, so on 13th January 2023, the government of India is released the detail of the National Green Hydrogen Mission. So this is a very good initiative by the central government. Okay, it's a National Green Hydrogen Mission. Okay, wherein it has been said out that government will commit INR around 20,000 crore to make the India global hub, okay, for the production and utilization and export the green hydrogen and it is a derivative. Okay, so this is a very good amount of central government take the initiative to make the green hydrogen technology in the India. Okay, so planning of our central government, so we need to make the hub of the green hydrogen in the India. Okay, the Ministry of the MNRE, okay, so we can say the Ministry of the New and the Renewable Energy has been assigned the responsibility for overall the coordination and the implementation of the mission. Okay, so MNRE is the take over this mission, there is a green hydrogen mission. Okay, the mission provides the roadmap for 2030. Okay, so now we have around 7 years to complete this mission. Okay, to make the India a global hub for the production, uses and the export of the green hydrogen and framework for the creation of the comprehensive green hydrogen ecosystem. So this content I take from the that is officially website of the India. Okay, so you can please search this green national green hydrogen mission, and as a faculty member we can submit our research proposal in this scheme. So that is a very good. So you can take the benefit of this scheme. So maybe central government will provide the research fund to doing the research on the green hydrogen electric vehicle. Okay. So National Green Hydrogen Mission continue, we can say development of the green hydrogen produce the capacity of 5 million metric ton per annum. So you can see production of the tentative plan of the production of the hydrogen 5 million metric ton per annum. Okay. So we can say the amount there is a Indian rupees is a 8 trillion investment. Okay, 8 trillion. This is a lot of amount. Renewable energy capacity addition is a 125 gigawatt. Okay, because it's a green hydrogen technology, so we can make the renewable energy storage capacity. So there is a renewable energy capacity additional of the 125 gigawatt. Because of the we need to produce the green hydrogen, there is a 5 metric million ton. Creation of the 0.6 million jobs. Okay, so there is also very good opportunity for the young generation, because in the India there is a less number of the job. Okay, so this is a very good initiative. And abatement of the 50 million metric ton of the annual greenhouse gas emission. So this is a very good. Okay, so we can reduce the CO2 from the environment. So this is summary point. So 17 for 90 crore for the strategy investment for the green hydrogen transition. 1466 for the pilot project. Okay, 400 crore for the R&D. So this is a total amount division. Okay, so how we can divide this amount, and 388 crore for the other mission component. So these are the amount division. So suppose you are targeting to write submit the project in the this emission, so you have 400 crore for the R&D. Okay, so this is a very good amount. Okay, so yes, so this is my last slide. There's a national hydrogen strategy shaping possibility for the Australia hydrogen economy. So this is already implemented in the year of the 2015 in the Australia. Okay, so you can just search on this website. There is a Australia strategy. So national hydrogen strategy. There is a shaping possibility for the Australia hydrogen economy. Okay, done. So up to here, that is your hydrogen, about the green hydrogen technology. So now I stop my presentation here. Okay, and now session is open for the question answer. And thank you so much for your concentrate on my presentation. Now this session is open for the question answer. Once again, thank you so much.
Yeah, thank you, Dr. Rajesh. Uh, any kind of research activities at present going on at TA related to this under your supervision?
Nowadays, around 10 BTech students working on this technology. So
Okay,
all of are the BTech student, but not any PhD scholar.
okay, okay. Mhm.
But I submitted my project in the SAV for this green hydrogen technology.
Okay. We wish you the best to get success.
Thank you so much.
Yeah.
Thank you.
So one student from London, PhD
Okay,
scholar, Pastor Graham, he asked questions in chat box. So I
okay,
will read it for you.
okay.
When considering the net zero emission, is the argument that the carbon produced during manufacture will be saved when using the vehicle. If that is the case, how can you evaluate that the carbon produced when crushing the EV in 5 years or 10 years or over 20 years is greater or lesser than the carbon produced while manufacturing the EV? Please re-explain if I didn't understand what you meant by net zero.
Okay.
Yeah.
So very good question and candidate from the London. So
Yes,
this
yes.
this FDP is international, correct?
Yeah, yeah, yeah.
So very good, very good. So nice question. So answer is net zero emission means that is a not like that while we design the any application. Maybe we can consider like a electric vehicle. Maybe we consider the electric vehicle for the example. So while design the electric vehicle 100%, that is a we can add the CO2 in the environment, maybe the 10%, yeah, maybe the 20%. Okay.
Okay.
Suppose our company's analysis this percentage of CO2, okay, while design of the one electric vehicle, okay.
Mm,
Suppose let's see, we can consider maybe the 10% of the CO2, we can produce the 10% of CO2, okay, while design the one electric vehicle, okay.
mm.
Then we have to reduce this 10% of the CO2 while running the electric vehicle throughout the life, okay.
Okay,
So
okay,
that is the meaning of the net zero emission. So
okay.
whatever amount of you produce the CO2 in the environment, then we have to also reduce the same amount of CO2 from the environment. Okay, maybe
Okay.
you can grow in the tree in the environment. Maybe you can give the new technology to reduce this CO2. So that is the meaning of the net zero emission.
Okay, 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 doctor. So the same student asked another question in the chat box. What is the second-hand value of EV? How are the batteries recycled? Is it worth recycling of EV batteries?
Okay, what are the second hand value of the EV and how the batteries recycle? It is about
Okay.
recycling the electric vehicle. Okay, so I don't have sufficient knowledge on the recycling of the battery, but I heard from the news as well as the Power Globe group. Okay, so nowadays technology is available to recycling of the battery. Okay, there is an electric vehicle battery, but that
Mm.
is a not 100% recycle because there is a chemical. So suppose
Okay.
you want to recycle this chemical, then maybe the some part of this chemical you can dump in the environment, maybe the
Mm.
land, yeah, maybe the sea area. Okay, so we
Okay.
cannot recycle the 100% of battery, and then we cannot say this is a 100% of the recycle of the electric vehicle battery, and we
Mm.
cannot say it is a 100% of the net zero emission because there is a not possible, and technology it is not like that we can 100% recycle. Suppose
Mm.
you can consider the simple your PCB, maybe the mobile PCB. So
Mm.
PCB there is a silicon material, and
Okay.
even solar panel is also silicon material. So nowadays technology is there to recycle the solar panel because life of the solar panel is maximum 25 years. After the 25 years we need to replace the solar panel with another panel. So what
Okay.
we can do with the solar panel? So we have a technology to recycle the solar panel, but it is not like 100% recycle of the solar panel. Okay.
Okay. Yeah. Uh, the student Foster Graham. I hope you got the answers.
Yeah,
Are
still
you
you
there?
are you not get your answer, then please let me know.
Yeah. Yeah. Okay.
Yeah, yes, I got my answers, but I just wanted to know the second-hand value of an EV. So is it worth buying it? Let's say you have a, would you go to the market to get a second-hand EV car? You know, like with IC cars, you can get a second-hand value. It has good ones, but is that the same for electric vehicles?
Okay.
Yeah. Thank you, Foster, for your good questions.
Sir, how do you
Yeah.
extract the hydrogen gas? And since it is also, if you go for electrical vehicle and all, it is something like carrying a hydrogen bomb with you. So, how do you make yourself so comfortable with this extraction of hydrogen and making compatible with electric vehicle?
Yeah. So hydrogen, there is a storage tank is there on the in the electric vehicle. Okay. So there is a not like that. So we can produce the hydrogen on the electric vehicle. It is not like that. So we have a storage tank of the hydrogen. So we have to refuel the hydrogen while drive the our vehicle. Okay. So we have a production area is different, and your usage area is also different. Okay. So it is the same like there is a petrol pump and a hydrogen pump. Okay. So once you have a hydrogen in the storage tank, and by using the fuel cell component, we can convert this hydrogen into electrical energy. So combination of the fuel cell and the hydrogen, we can make the electricity. That's why I presented one slide how we can produce the electricity from the hydrogen. So one component is a hydrogen and another component is a air. So air is a free, okay. So we need to just give the air pressure according to regulation, okay, and then we can generate the electricity, and that electricity we can give the our electric motor. But on the board, we cannot produce the hydrogen in the case of the fuel cell electric vehicle. I hope you got the answer, Pawan. Yes, Pawan, you got the answer. Yeah.
Pawan, okay, maybe it's disconnected.
Yes. Yes. Yeah.
Yeah, any other participants would like to have any comments?
Hello, sir. Am I audible?
Yes. Yes.
So at slide number 6, we discussed that EVs are having a low running cost by considering cost of electricity. By considering the cost of electricity, we need to charge the vehicle only. But when we drive the vehicle, our batteries are also degrading. And at some time, let us say 10 or 15 years, we need to replace the battery also. So, should we include that cost also in the running cost? What's your thought on this?
Yes, of course, we need to add this cost also because there is ultimately addition of the amount, correct? Suppose you want to replace this battery, then price of this battery maybe the 10,000 rupees, depend on the capacity of battery, okay? Maybe the 5,000 rupees, okay? So we need to also add this amount while we calculate the budget for the electric vehicle. Suppose initially you can invest the budget for the two-wheeler, maybe the amount is a 1.5 lakh rupees, okay? And suppose the battery life is maybe the after the 5 years, yeah, maybe the after the 2 years, you need to replace because every year there is a degradation of the energy efficiency. Okay. So maybe the after 5 years you have to replace that battery because it is not possible to drive our electric vehicle. Okay, so 100% you have to replace that battery. Okay, then we have to add this amount on the running condition. So as per my slide number 5, we have to add this amount for the our total budget as per our running cost.
Okay, thank you, sir.
Most welcome. Nice question. Yes, any other question from the audience? So we have an international audience as well as the national audience. That is a very good. And question is also very good. Nice question.
So I have one question.
Yes, yes, Shivam sir. Yes.
Suppose if we are able to match or not match or at least get faster charging of our battery vehicles, which is the limitation as of now, which is ranging from 30 minutes to 1 hour 30 minutes for fast charging. If we try to reduce it to 5 minutes, then what will be the comparison of B at electric vehicle and hydrogen? Because that is the challenge because of which we are moving to the fuel cells as one of the challenge, that is charging of the charging time. So if we are able to reach to 5 minutes, let us say, of charging of our electric vehicle battery, then in that case, if we compare, then who do you think will be a better solution or option if cost is not an issue?
Yeah, then of course, electric vehicle is very good compared to the fuel cell electric vehicle because hydrogen is a very dangerous. Suppose maybe the 1% of leakage of hydrogen in the environment, then it's a very dangerous. Suppose cost is a not issue, but I am sure while maybe the charging is maybe the it will take only 2 to 3 minutes, yeah, maybe the 10 minutes. Then of course people is going with the electric vehicle, not the fuel cell electric vehicle, because there is a two issue. One is the storage element. Hydrogen is a very dangerous. Okay, and second is the cost of the electrolysis is also very high.
So I think maybe in coming years we will be reaching fast charging.
Yes, of course.
Looking at the speed which with which the research has progressed.
Yes, of course. Nowadays, many companies as well as a research scholar are working on the fast charging topology. That is a very good.
So for that we also need to look into the battery characteristic, right? How much
Yes.
current the battery is able to take.
Yes. Nowadays, people are going with the SOH, state of the health and state of the charge and thermal management system, everything like that.
Because I've heard the F1 Formula One race, there is also electric car race is also there so there
Correct.
it's very much useful to charge the vehicle, as well as the inverter which is used to transfer the power from battery to the motor. That is also a very powerful motor,
Yes.
powerful inverter.
Correct. 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 So that's why I'm said now. So power electronics is the heart of the any application. Without power electronics, we cannot do anything. So suppose you want to go with a fast charge, and then of course power electronics is heart.
Okay, okay. Thank you. Some question is there in the chat box.
Yeah. Not there are the 500 kilowatt charger that can be charged 90 kilowatt hour battery from 20 to 80% SOG in
Yeah,
5
yeah,
minutes.
yeah.
Yes. Yes.
So I
So in
think
which,
this is basically for the buses, right?
yeah.
Not for cars as of now.
So there is in UK. I think there is in UK. There are the 500 kilowatt charger. So I think in
Yes.
India there is not possible. I think UK is possible. Yeah.
Yeah.
Yeah. That is a very good.
Right.
Yeah, the student is saying from the world, London.
Yes. So yes. So in the UK, so how many percentage of electric vehicles are there? Maybe the 10% or 20%. Any idea?
Compared to ICE is about I'll say 2 to 3%. There are just about 50,000 in total that have been bought as at last year's data. So the comparison is low. It's low because many people are skeptic of going to EV because of all the disadvantages. Yeah.
Okay. Good. Thank you. So one more question from the Vishwanath. Is it possible? Is there possibility of the onboard charging battery electric vehicle using the hydrogen fuel cell? Yes, there is a possibility, but normally we are not preferred to charge our battery using the hydrogen fuel cell. Suppose you want to charge your battery on board using the hydrogen fuel cell, then ultimately increase the weight of the vehicle. Okay. So whatever you reduce the time as well as the energy during the onboard charging, then that more amount of the weight you can aid while charging through hydrogen fuel. Okay. So as a technically we can charge our battery on board, but practically nobody will use this concept. Obviously to charge our battery it is required only electricity. Okay, but practically we cannot do this because ultimately increase the weight of the vehicle, so we need to give the more power to drive our vehicle, but technically we can say it is a possible. Yes. Mansuri have any query? I think yes, you can
Yes,
unmute
sir.
and you can ask. Yes.
Yes, sir. Sir, according to diagram 17, slide number 17,
Mhm.
what size of the battery has to be selected for fuel cell?
Oh, so very good question. So there are the many parameters depend on the choose the battery for the electrolysis process. Okay. So recently my paper accepted for the conference in Bhubaneswar. That conference will be happen in the Bhubaneswar in the IEEE effect. So I given the step by step process for the selection of the battery for the hydrogen fuel cell. So there are around like many parameter involved to consider the size of the battery in the case of the hydrogen fuel cell vehicle.
Okay. Thank you, sir.
Most welcome. So Dr. Tirumurugan, you have a good amount of the audience and very good audience. So there are all are actively participant.
Yeah, thank you, Dr. Rajesh. Yeah, it was.
I think you and Dr. Shivam sir have a good effort on the organize this webinar and publicity for this webinar.
Yeah, yeah. Thank you. We did it for very short notice, in 2 weeks. Right.
Then also very good this is. So audience is very good even.
Thank you. Thank you. So your talk is very informative, and we learned from you many things, sir.
Thank you.
With
Thank you
this
so much.
note, I'd like to, on behalf of VAT, we give you the token of virtual token of appreciation. Please kindly accept it, sir, for your expert talk.
Thank you so much. So this is very good. So as an online talk, maybe in the future we will visit in your campus.
Yeah,
Maybe
yeah,
sometime you will visit in the Thapar, and sometime maybe I will visit in the VIT.
yeah, yeah,
Okay. So then
yeah,
it's
sure,
very good.
yeah, yeah, sure. Thank you.
So thank you so much for this token of the appreciation.
Yeah,
And once again, thank you for me. Thank you to invite me for this FDP program. Okay.
okay.
And now I think we can stop this session, and I think next session will start.
Sure, sir, sure. Thank you so much.
Okay.
Thank you so much once again. It was very informative talk, and I hope all the participants have enjoyed and learned something new. And if possible, sir, can you give your email ID in the chat box, so in future, if any of the participants want to have some doubts or clear some doubts, they can contact.
Sure.
Sure. So to participants, our next session will start at 4:50 p.m. and yeah, so I request you to get back at 4:50 p.m. Indian Standard Time. Okay, you can note down the email ID if anyone wants. They can contact Professor and clear their doubts. So once again, thank you so much for for giving the speech, and so we hope that you also like the session, and
Yes.
maybe in future we will also try to collaborate and work in some domain.
Before concluding, Dr. Rajesh sir, I'd like to add one note. Dear participants, Dr. Rajesh is very actively participating in IEEE activities and area region 10 chapters and all. If you are anybody willing to involve in IEEE activities such as conference and travel grant or various technical events, you please contact Dr. Rajesh Pindoriya. He will guide you, or he will at least give you the correct way to approach. Since the last 6 or 7 years, he is actively involving IEEE activities. I like to add on it. Also, maybe Rajesh sir can add 1 or 2 points here if he wish to.
Yes, Dr. Tirumurugan. So IEEE is we are an academic person as well as the industry person. IEEE is a benchmark. Every in the as well as a standard process, we can use the IEEE standards. So as a faculty as well as the research scholar, we can take the benefit from the IEEE. Okay. So you will get a lot of benefit from the IEEE once you are active in the IEEE member. So since last 10 year, I'm a active volunteer in the IEEE. Okay, and now I'm a Region 10 area chapter chair of the IS South Asia. Okay, so also I am involved in the global level activity. So suppose you have any query and you would like to know more about the IEEE, how we can get the benefit. Okay, then please contact me. I already given my email ID, and you can also take my mobile number from the Dr. Tirumurugan. Okay, so there is not issue. So we can discuss over phone. So what are the benefit and everything. So as a research scholar, as an academic person, as well as as a industry person, I can suggest you please take the IEEE membership, because amount is a not very big amount. As a research scholar, amount is only $27, and as a senior member as well as the faculty member, amount is only $76. Yeah, around $86. So amount is a not very big. Okay, but you can take a lot of benefit as a professional benefit.
Yeah, thank you, Rajesh sir, for adding this last important.
Most
Yeah,
welcome.
yeah.
Yeah.
Okay, so we will conclude the sessions and we will meet again at 4:50 p.m. Thank you so much, sir. Thank you so much.
Most welcome. Thank you so much. Okay, bye.
Bye.